Hi, my name is Tessa with Bridger Photonics, and today I want to share with you a little bit about gas mapping LiDAR, an aerial methane detection and quantification technology. Our mission is simple: enable clean, safe, and streamlined oil and gas operations by providing actionable data for methane emissions reduction. With that mission in mind, we developed gas mapping LiDAR to make emissions reduction simple. We attach a laser sensor on the underside of an aircraft, then sensitively scan oil and gas infrastructure throughout the entire natural gas value chain, from production sites like I'm showing here, to gathering pipelines and booster stations, to transmission pipelines and compressor stations, all the way down into cities where we're scanning entire metropolitan regions for utility companies. We then hand our clients a map that pinpoints, images, and quantifies every important emission source in their infrastructure. We currently operate in all major production basins in North America. We're using many PHMSA-compliant leak management plans for the transmission sector, many alternative methods to replace ground crews in Canada, and last year we were submitted by ExxonMobil as the first ever alternative means of emissions limitation, or AMEL application, to replace ground crews for EPA Quad compliance in the U.S. Some highlights over the past year include that AMEL with ExxonMobil. They vetted 8 different technologies head-to-head, and they selected us to include in the AMEL application. They're hoping to use gas mapping LiDAR to meet regulatory requirements instead of right now where the EPA requires them to drive to each site, get out of their cars, and scan every piece of equipment with an OGI camera by hand. We have strong evidence that not only does it take less money and time to fly, but we also catch more emissions. Exxon realized there was a better way, and they submitted this application. On the other end of the supply chain, we're scanning for the nation's largest gas distribution utility. SoCalGas in California brought us on for their first ever service area wide aerial methane emission scanning. So we're scanning their service area from Fresno all the way down to the US border with Mexico, their entire distribution network. A highlight from late last year is our work with Diversified in the Marcellus. They've committed to full transparency of their results and a 3-year commitment to scan their entire Appalachian Basin. And most recently, Devon announced that they'll be scanning their entire inventory twice this year with gas mapping LiDAR. So what is it that differentiates gas mapping LiDAR? We've spent a lot of time fine-tuning it to get it right, and we found that there are 2 big differentiators: the actionability of our data and the sensitivity of our technology. The actionability of this data speaks for itself. Looking at an example data product like this, you can see exactly where you need to send your crews based solely off this image. In addition to the visual appeal, this flows directly into GIS systems with data on the exact location with GPS coordinates within 2 meters of the emission source, imagery of the plume, and quantification of each plume so operators can prioritize repairs. We provide aerial photography so operators know the status of the site at the time we flew it, and we can provide the option to identify equipment like you see here. Our actionability makes it simple for operators. The other piece of this is our sensitivity. We like to use other people's words to describe this, like Matt Johnson from Carleton University, who said gas mapping LiDAR is 15 times more sensitive than the competition. And we found that Matt's estimate is actually conservative because it's based on controlled releases. In actual field operations, we find that gas mapping LiDAR is a factor of 50, yes, 50 times more sensitive than the competing solar infrared technology. Matt Colasar from ExxonMobil said that at a minimum, we believe that Bridger Photonics was going to get at least 90% of the emissions from our assets, and that benchmark was critical. We hammered on that benchmark because we want our clients to be able to look anyone in the eye and say we're using a technology that detects more than 90% of emissions in a given basin. And Pioneer Natural Resources in their sustainability report stated that using a higher sensitivity technology allows us to understand the full picture of our methane emissions, which leads into this plot. This shows the percentage of emissions that we detect for 5 different basins versus the detection sensitivity that we need to detect that percentage of emissions. So take 50 kilograms an hour. In one basin, that'd get you about 18% of the emissions. In another basin, it'll get you about half. So you can see that if you use that sensitivity of 50 kilograms an hour, you'll get in this ballpark of 18 to 50%. The EPA has proposed an emissions detection sensitivity of 10 kilograms an hour, which puts them between 60% and 82% in various basins, which is pretty consistent with their goal of reducing emissions by 75%. We operate with a detection sensitivity of 3 kilograms an hour in the production sector. In the distribution sector, We can go even more sensitive, but we choose not to in order to ensure that producers are focused on meaningful repairs. Well, that's all I have time for today. Thanks for your attention. Please don't hesitate to contact us with any questions you might have.